Yeah,
Hi, everyone, and welcome to this week's Data Science Office Hours. For those of you that I haven't met yet, my name is Ryan Rosario, and I am a mentor for the intensive and career track. Today, we have a project presentation from Shakir, who was in the Data Science Intensive program with mentor Ankit Jain. Today, he'll be presenting his capstone project. And the way that this works is he will present for about 10 to 15 to 20 minutes, sorry, on his project from start to end. And then the last 10 to 15 minutes, we will take questions from all of you. So if you have a question while he's presenting, go ahead and type it into the sidebar, into the chat window on the side of the screen. You can either send it publicly or privately to me. And then when Shakira is done presenting, we will pick as many questions from the sidebar as we can. Usually we get through all of them in this type of session. You can also use the raise hand feature, and then we can get you on microphone as well. Usually these sessions aren't like packed to the brim, so we can get more questions answered and have you on the mic as well. So let's welcome Shakir, and go ahead and take it away.
yeah. Thank you, Ryan. Hello, everyone. Let me introduce myself. I'm Shikhar and completed the data science intensive course 2 months ago, and my mentor name was Ankit Jan. So I'm feeling very excited to present it. So first time for me, I'm presenting this capstone project to a larger audience. So my capstone project was based on a classification model, which has been taken from UCI machine learning. So I given name uh, for this project was machine learning for risk management. So source was UCI machine learning, and the data set has got 30,000 rows, and it has got 24 attributes. Uh, a data set was about credit card credit card default rate along with their features. Okay, it was the default rate of being a male and female, as well as their attributes such as amount of given credit to individuals or family, their gender, their education status, marriage status, age, and history of payment from 6 months period when the data set was taken. It's a historical data set. So UCI machine learning is all about an archive data set. So this is all about a data set, and the problem statement was about I started aiming the customers who was at default payments, and I mean category was male and female, and what is the chances of getting default, and they're comparing their predictive accuracy of probability of default using different classification methods in supervised learning. So I have started building a few data stories before started working on machine learning. So my objective was what is the default rate on their credit card payments for different categories, male or female. So coming to the next, these are the exploration from data set itself before starting actually working on the machine learning part. So proportion of females were more in the data set. So obviously the graph will lean towards for female itself. So that is the reason I started building a data story, so that I'll not get away. I'll not get into the machine learning straight away. Okay, at least we should have an idea which on which side which kind of category has more a kind of default rates, because sometimes what happens when number of records is too high, so obviously you're gonna say okay, female has more rate of default. However, the results are a little bit different. Okay, so when I compare the result sets using the different attributes, I came to know uh, the marriage university pass out females are more likely to default than who are graduates in high schools. Actually, there were three categories in education. One was married, another one graduate, and then the third one was high school. And as I said, most of the most of the features which were actually predicted the default rates correctly was age, gender, as well as what was that? Yeah, age, gender, and one more thing was there. Just let me. Yeah, the amount of credit given. So it is started that way. Okay, sorry. Um, yeah, coming to the next. It happened for a single male and female also. I'm sorry, single female also, because again, single female university students are also likely to default more in comparison to graduate student. So it is not related to their marriage status, even if it's a university pass out, or marriage university pass out, or single female university pass out, the default rate is always high than the other categories are. So that's the reason I presented it in the slides, so that at least people have a clear idea about it. Same thing happened with males who are university pass outs are also likely to default as compared to graduates. Just let me know if I'm going a little bit faster. Okay. Yeah. So this is the next slide showing married university pass out males are also more likely to default than graduates are. So the same story I just trying to build if I can achieve something. So before going to the machine learning part, I try to build few assumptions or recommendation, I would say. So as per the data sets, I mean, if I look as per the data analyst part, not before applying data science, so I would say the credit card company should or bank should target to provide credit cards to males as compared to the females. Reason being, there were more females getting default, as I mentioned in the first slide. It's the very first observation which I had on the when I'm looking at the data set. Always do the education status check before providing credit cards to the client, as proportion of default is very high. As I mentioned, university pass out graduates, pass out students were more likely to default. So it's better for credit card companies to do at least education status background check, or they should be cautious when giving credit card to such category. So these were my assumptions, as well as there should be lower limit schemes for university pass out male or females, because it was common for both the categories. The university pass out graduates are more likely to default in as compared to the graduates are. So they can plan to give a more schemes for them. Okay, they should not default, or maybe they should be having a very cautious about these kind of students. So now, why we wanted to apply machine learning for this data sets. So I mean, we build a story. Now we wanted to have a kind of evidence. Okay, if my machine learning model is saying the same story or not. So we will try to find probability of default among females as well as males, and to achieve this result we'll build classification models, as I mentioned earlier. Any questions so far, or anything if it's not visible, just raise your hand, guys.
Thanks. Yeah, we had somebody who couldn't see the presentation, so I wanted to make sure it wasn't everybody. It looks like it was something a one-off thing. Yeah, we'll go ahead and take questions, everyone, through the sidebar, and then when Shakir is done talking, we'll definitely pick as many as we can.
Okay. So coming next to the machine learning, just a minute. Yeah. So these are the supervised learning methods, or you can say the classification models, which I have used for my capstone project. So random forest, as you know, it's a combination of ensemble methods, SVM, in which it's a support vector machine model. I think most of you are aware of it. And the most important thing about SVM, the features should be scalable. And then I picked up logistic regression. The hyperparameter, or I would say a regularized parameter, is most important when you are doing logistic regression. For k nearest neighbor, we have to choose the best neighbors to make the optimized optimized predictive accuracy of the model. And then Naive, it is actually used for text mining, but there are three types of models in Naive itself. I try to use it, and I make sure that features should be independent from each other. So I started with logistic regression. So what I did is I apply the machine learning on all the features, and then started building it and got an accuracy of around 77 or 78. And then I realized something to do with features as well. I tried to use SVD as well as uh, PCA, but it didn't help me much. So I tried with trial and error, and got few features which was not actually being used, which is not worth it to be used in the data set. So few features I have excluded, initial amount of balance given, which was a part of data sets. It's something, what is your limit? Okay, what's your limit in credit card which company provides you? It has nothing to do with predictive model when I apply the machine learning. And then the bill amount which was charged on client's credit card for last 3 months. So there's at least 8 to 9 features were there on bill amounts, and the amount of previous statement, and how much the bill paid by the client itself. So again, these features were not actually helping me to build my model, so I've excluded them and got the highest accuracy in logistic regressions. So for to avoid the overfitting of the I'm sorry, to reduce the variance, I try to use a regularized parameter, and to get the maximum optimized parameter, I have used cross validation. It was the best estimator to do, and then I got the accuracy of 79.53. So it was better than before. This is the ROC curve. Those of you who doesn't know about ROC curve, it is a curve between when you plot between true positive rate and false positive rate. It is actually go above this line, the diagonal line which you are showing, which is shown here. So it should actually touch the upper part, but for my data set, it is showing me only just above this diagonal line. So that's why I went for different classification model. So it should be like a curve which is touching the upper corner. Okay. I mean, for most of the data set, if you have having accuracy of 90, 95%, 96%, so it should be a kind of curve itself. Then I choose a support vector machine. As I mentioned earlier also, your features should be normalized, because as I mentioned earlier, my data set uh, was about the features. How much is the credit card limit? Okay, it should be in thousands, in millions also. Not in millions, yeah, then 100,000 kind of limit was there. And on bill payment, there was some negative values in the data set itself. And again, age is just a 2-digit number. So a feature should be normalized when you're using support vector machine. So there was a catch here. I try to normalize my data set based on the testing data sets, because if the reason to say so, to doing so, was if you don't have so much if you don't have so much examples in your uh, when you're testing it, so your results would be different. So try to um, normalize my training data set based on the testing average, and the, what is that, SV, what do you say, sorry guys, I lost in between. It's about deviation, sorry, standard deviation. So I normalize this based on the testing data sets, attributes, deviations, as well as the average. Okay, and I use the cross validation to best the best slack as well as gamma. So these are the parameters which I got to optimize my model. C was taken as 1, and gamma was 0.001, and kernel used was RBF. You got 2 kernels, and you have to check using cross validation which one is best. One is linear, second one is RBF. So I got this kernel to be used using the cross validation. So optimized accuracy, when I compare my result, it was 78.24. Even if I excluded few more features, which was almost the same. You have to exclude initial amount credit given on the credit card and what was the bill amount. The same story which mentioned you in a logistic regressions. And the disadvantage with what support vector machine was it took me almost 2.5 hours to train my model. Every time when I train it, it took almost the same time. So I'm not a big fan of support vector machine for this model. So ROC curve, it's pretty weird. It's the line is almost a diagonal line, and that's the reason I got the lowest, not the lowest, yeah, lowest accuracy, 78.24. So I will not recommend using support vector machine for such kind of model. Yeah, coming to the next k nearest neighbor. The same features were excluded as was in a logistic regression. And to get the maximum neighbors, I mean, sorry, not maximum, the optimized neighbors, I used a cross validation, and I got the number for neighbors, which was 30 using the cross validation, and the accuracy achieved was 78.65%. I think I don't need to mention how k nearest neighbors. It's all in scikit-learn, and just go and use it using the cross validation to optimize your model. This is the ROC curve. Not very good. True positive rate and false positive rate. Since accuracy is not too high, so it is bound to happen like this. Then I tried to use naive Bayes. I made sure that the features should be independent. Otherwise, it will not give me the accuracy. Actually, it happened with me when I was not aware of naive Bayes. I just started building the model, and it gave me the accuracy of 36%. And later on, I went through the tutorials and came to know that a few features should be independent, and that way I applied naive Bayes, and accuracy achieved was pretty high, 80.38%. And similar features has to be excluded. Just that the features which were included in building the machine model, building the machine learning, it should be independent. So this is the ROC curve achieved for naive Bayes. The next one or last one in the presentation is random forest. So I call it as a savior for my capstone project. A reason to say so, when I compare the graph, it gave me the highest. Can you guys see? Is it my screen clearly? The first one in a random forest. Yeah. So it shows the graph is going pretty high above the diagonal lines, better than others. The reason to compare is to show, yeah, why I call it as the savior machine learning method for my capstone. So yeah, no normalization needed for such kind of classification model, and obviously more features were excluded, such as history of payment for last 4 months. So I have excluded one more feature, which was telling me about what was the history of payments made by clients. So it was again not relevant to build my machine learning model. And this algorithm was pretty fast to predict the model. And again, I used the cross validation to pick the best features such as a number of trees, how many trees you wanted to include. When you go for random forest, you come to know, okay, uh, in decision tree, you go, the algorithm goes and check one features one by one, but in random forest, you have a random set of features which can be taken together and to build the best to give the best accuracy. So number of trees was 20, and maximum depth, how deep you wanted to go in random forest. So it is about the maximum depth. So it was 7, and that gave me the highest accuracy of 82.77. So far the best estimator and the best algorithm I have used for my capstone, and this was the highest accuracy. I know it's not that much high. People are building models and giving the accuracy of 96, 97, but that was I could have achieved. I tried different models. However, 82 was the highest one which I have got from random forest. And this is the ROC curve, receiver operating characteristics, and it's got a high. If compared to other algorithms, it's pretty high than others. And so this is the cross this is the tables which will give you the predictive label as well as the true labels. And yeah, so that was my part of presentation. Any feedback, any questions you guys have? And if you don't get anything, if just let me know. Have you got something? Yeah.
Thank you, Shakir. If anybody has any questions, go ahead and type them into the sidebar. Don't be shy. You can also raise your hand using a feature within the system. If you can't figure that out, that's okay. You can just get on your mic, unmute yourself, and ask your question. I always start first because people tend to be quiet or shy during these. I have some feedback.
Okay.
You're on your rock curves. It's
Yeah.
really unfortunate that it appears that those weren't reviewed because you have a minor bug that's causing the rock curves to look the way they do.
Okay.
Um, it's because you used, when you called the function to create
Mhm.
the rock curve, you
Yeah.
called predict rather than predict proba.
Okay.
So you need, yeah, perfect. You have the code. So you need to predict probabilities, not class labels. If you predict class labels, your rock curve is going to look the way that they do. I've seen it
Okay.
several times now. So if you use predict proba though, and use that for the rock curve, then you should get a better situation.
So you are saying, can you see my screen?
Yeah, so scroll up. You have Y1 test, Y1 pred. I see that. So scroll up
Yeah.
a little bit so I can see what's before that. Uh,
Y1 test is, both of them are predictive one. So Y1 test is the class label
yes,
0, 1, and predicted is a predictive one from the model. So you're saying it should be
that should be a probability, not the predicted class.
okay. Probability of default. You are saying
Yes,
uh, this one.
yes, yeah, that should be Y1 pred.
Okay.
That's why your rock curves look so weird. Uh,
Okay.
and they should look a lot better, and that means your AUC then should be a lot better.
Okay.
Although your random forest model is clearly the best one because
Yeah.
even though the rock curve was still messed up, it was still
Yeah.
the
Yeah.
farthest from the diagonal line, so it's
Yeah.
probably still the best model.
Yeah.
But yeah, I mean the one where you have the curve right along the diagonal line, that's like the worst case scenario.
Yeah.
And
SVM. Yeah.
yeah, and it doesn't match your results because of that bug. So it's unfortunate because if somebody would have checked that, your rock curves would have looked a lot better probably.
Okay. I'll try to change it.
Yeah. Let's see, what else did I have comment on? Oh, so you focused on accuracy quite a bit in your analysis. Uh,
Yeah.
how is the balance of your data set? So is it 50% default, 50% not default?
No, it was about 70-30.
Okay. So your base rate then for accuracy is about 70%. So if your
Yeah.
accuracy is 82%, you essentially got a 12% lift. Accuracy, when you have an imbalanced data set, is very misleading. Um, in your case, it may not be so much so because the split isn't too bad. But instead, what you'd want to do, especially in an interview, you'd want to look at other performance metrics, usually precision and recall and F1 score. Give you more information when you have an imbalanced data set. AUC is also pretty good. I could tell from your confusion matrix that your
Okay.
method has pretty high precision, which is good.
Okay.
So that would be probably a better metric to use in that case when you have an imbalanced data set. The classic reason for this is that if you can have a dumb classifier that just labels everything as a default, and it's going to be correct 30% of the time automatically because 30% of the data are defaults, assuming
Yeah.
30% are defaults. So you can't really compare accuracy to the usual 50% threshold in that case. So that could be a little bit misleading, but it's
Yeah.
not too bad in your case. If it was like 99.1, it would be bad. But here
Yeah.
it's 70-30, so it's not as bad. You mentioned normalizing using the testing set.
Yeah. That's correct.
Yeah, so usually what you want to do is you want to normalize using the validation set. So the reason why you don't want to normalize on the training set is that it can lead to overfitting. So you
Okay.
want to have a third data set called a validation set that you
Yeah.
base normalization on. And when you pick the parameter C and gamma and all that stuff, you want to use the validation set. Either that or you want to use k-fold cross-validation on your training set. It'll help you avoid overfitting. But you typically never want to do anything with your model using the test set, because then what'll happen is you'll end up overfitting. Then
Okay.
you're essentially training the test set to act more accurate, essentially.
So, okay. So I checked with Amit, my mentor also. I started normalizing using my training data set. So he only mentioned use it through testing. The reason being, Ryan, if we don't have so many data set in test, so how it will give us the best accuracy? So that's why I did it on
Oh,
testing.
I see. Okay, I misinterpreted what you meant. Okay, yeah, yeah, that's fine. I thought you. Okay, yeah. So should be done based on the training data set. That's correct. Yeah, so you want to do it based on the training data set, and then what you do the training set, you want to do with the test set. Okay, perfect. So anybody else have any questions? Go ahead and get on your mic. We have a couple minutes. Questions or comments, or type them in. Don't be shy. Okay, I'll go ahead and ask another one. Um, do you have data on grad school status? So you found that I think males that graduated college, or maybe it was females that graduated college, have the worst default rates. Did you also have information on graduate degrees?
Yeah,
Okay, so
yeah.
you had masters and PhD in there as well.
No, no, no. It's just university pass out, graduates, and high school. That's it.
Oh, okay, okay. I imagine you didn't have major.
Sorry.
You didn't. I imagine the data didn't contain the major.
It's all more on university pass out. So which I shown you in the graph itself
By
when I was.
major, I mean field of
Yeah, yeah,
study. What the
yeah,
degree
yeah, yeah.
in.
So it's pretty high in case of university pass out.
Hmm. Okay.
And
Yeah, the reason why I ask is because there's a lot of discussion these days about certain types of degrees, and particularly STEM degrees versus STEM being science, technology, engineering, and math, versus
okay,
liberal arts and humanities degrees like art, English, and all those kind of things. And what I was curious about is if there was a difference between the STEM majors and their default rate, because the theory is that they make more money or have an easier time finding a job, so shouldn't default, versus the
okay.
non-STEM majors, which in the U.S. Uh, can sometimes have difficulty finding employment. So that's why I asked that, but that's no problem. I figured that wouldn't be in the data.
Okay.
So we've reached 5:30. If you have a quick question, ask now or forever
I
hold
have.
your peace.
Yeah, I have a question.
Yeah.
So, as you mentioned, for balanced data set, we can go for highest accuracy if it
Yeah.
is a 50-50. And if not, then if it is going high, as in my case, 70%, so we should use the precision and recall. What about the p-value and all? Should we? Because in some of the videos, by Alan Donny, he said we are not using p-value anymore. When I checked with my mentor, he's saying no, you can always go for the p-value and hypothesis testing. So
Uh,
I'm a little
uh,
bit confused. Should I go for that or not?
so for logistic regression, you get a p-value.
Yeah.
You might also for the random forest. I don't think you do for KNN or SVM. The p-value isn't going to give you a whole lot of information about how well the model predicts. It gives you information about how influential the features are that you included. So if your overall p-value is below 0.05 for the model, it means that your model significantly predicts something, but it doesn't say how well it predicts it. It basically means that at least one of the features is significant and helps to make a prediction, but it doesn't quantify how well it'll make the prediction. You can also get p-values on features, and all that p-value tells you is that the feature is relevant to the prediction, but it doesn't quantify how relevant it is, how well it improves the fit of the model or the prediction from the model. So p-values are good and all, and it's good if all your features have low p-values, but it doesn't tell you how well it acts on test data.
Okay. So is it used in a real world nowadays? It's been completely abandoned, or because Alan says that yeah, no longer no point to use p-value. So is it true or
It's pretty true. Especially in machine learning we focus on accuracy, AUC, precision recall, F1 score, and a bunch of other stuff. For statistical modeling, for example, in regression analysis, p-values can still be useful, particularly since you don't usually separate your linear regression results or data into a train and test set. You usually just look at the residuals versus fitted plot, the quantile plots, and to make sure that the underlying theory is valid. So p-values can be useful in the classical statistics, but whenever you're trying to predict something, meaning mostly classification, you're not going to use a p-value. For regression, or forecasting, you may use a p-value more, but the focus should always be how well does it perform in the context of the problem, not what the p-value is. I typically use the p-value to back up my data story. So if I'm having a hard time explaining that there's practical significance with something, I'll often rely on the p-value to back me up, but I don't rely on the p-value first.
okay, okay, okay. Thank you. One last question. I'm working on few more data sets and few data stories as well as later on I'll build a classification model.
Hmm.
So is it be possible if we got time, or can I ask to Ken if I can present it, maybe not coming soon but maybe a month after? Is it a kind of privilege we got in this course?
Yeah, you could ask Kane that. We
Okay.
always like to stay in touch with mentors through the community.
Okay.
Sure, people would love to see, whether it's in this forum or as a blog post or something like that. I'm sure people would love to see what you're working on. So yeah, you could ask her specifically about presenting in office hours. You could also record a video if you want. Or organize a talk like this using Google Hangouts or something, and
Okay.
post a link in the community, and then you can have students and other alumni and mentors come and give you feedback and ask questions.
Okay. And is the which is the best blog where I can my project can be visible to the companies? I'm using LinkedIn only. So do you think about something else, or I haven't got any call so far?
I would, yeah, yeah. So usually, yeah, so blogs can be tough. They can take a while to gain traction.
Mhm.
I would encourage you to just keep blogging, uh,
Okay.
to publish your blogs on Twitter, Facebook, anywhere that's a social following, and get into
Okay.
that data science group, even if they don't know who you are. On Twitter, it doesn't
Okay.
matter. Just follow data scientists, and if they like,
Okay.
right, they'll follow you back and follow your blog posts. Um, I don't think there's no preferred blog format or anything. Just go
Okay.
for it, and if what you write is good and people are interested in it, it doesn't matter what blog you use.
Okay. Actually, I'm working on a Twitter data sets. So next is it'll be on text analysis.
Great.
Yeah.
Okay, everybody. We're past 5:30, and nobody has any questions, unfortunately. So we'll go ahead and close out.
Yeah. Thank
Let's all thank Shakir for his great project. And next week we will, join again at this time. Not sure the topic yet, but that'll be Kane will post that, and we'll see you all next week. And have a great weekend, everyone.
thank